all of your business emails from the plane onto notes to send to all the clients that you might be late meeting. It was a fun rapid fire CNC machine experiment. Yeah, so that's me. I just put it here on the website. So yeah, let's flip to an image that will be tolerable for the rest of the day. Okay. Let me do that demo I was talking about. So these things, I'm going to be demonstrating how to build a Borgatti. So this is an open source technology. You can download all the files and 3D print all of the molds required to make these guys yourself. I'm not saying it's the easiest or the cheapest thing that has ever been created, but it is open and it is accessible. So this is Borgatti. I don't need to block anybody's view. No, I'll pass these guys around. There's not too much that can hurt them except for overinflating. Open up the path into a moving robot.
Very.
So this is a quadruped that only has 2 input channels. So just the way that the silicone is made, there are internal chambers to the left-hand side and the right-hand side that fit together inside of the mold. They're made originally with cores, with wax cores that are then melted out, and so once the silicone matures around the wax cores, those melted out areas make hollow spots. Those hollow spots get inflated with air, the air causes distortion causes the movement. So these guys can be powered with just about anything. I use compressed gases much of the time, but that's not the only option. I don't do much with hydraulics because I find that hydraulics are pretty messy. I once worked on a job. I gutted a clean alien from the movie Alien vs. Predator 1 so that we could use all of our guts in Alien vs. Predator 2. And all of the hydraulics were the messiest, biggest nightmare I have ever played with. Hydraulic fluid is gross. And so I decided to not...
Never owned a Citroen.
I also have never owned a Citroen. But
World's greatest car, all hydraulic.
I tend to avoid hydraulics if I can. So, there we go. So this is a part I made, just to make sure there's nothing that's going to twist it over here. So this is a part I made that is a single piece silicone casting, so the silicone gets cast with a core. So this is the mold that made that. So it's just a 3D printed mold, 3D printed core. If everything is printed correctly, doesn't require the silicone to stretch too much to get it off of the core, I can have this in one part as long as I apply a mold lubricant. I don't work for Smooth-On or anything. I just tend to use a lot of their stuff, and so this is the particular one I use. I use universal mold release for a lot of my silicone stuff. I use a Smooth-On silicone called EcoFlex 0050. That's just the durometer of the silicone. And this is that guy. It's a 3D printed mold, 3D printed fitting, and it's currently pretty happy at about 2 psi. I could let this just continue going and it gets disturbingly large. I've not popped one of these guys yet, partially because at a certain point I get sort of terrified of them.
Will you try today?
So that's the general idea.
How big does it get? How big did you make it?
Let's see.
About that big. About that big was my max. I will video testing this guy. But that's pretty tight. So yeah, that's just one of these guys. If you want to pass it around, you can sort of squeeze it and look at the fastener. So that's my general methodology. I'm trying to get really rapid fire.
Pretty sensual.
So the idea is rapid fire molds, rapid fire casts, trying to iterate as quick as I can so I can find working solutions. I don't want to spend that much time simulating if I can get an actual benchtop prototype and get one to play with. Because then I'm more likely to figure out what's wrong than having a simulation, then make one, then have things still be wrong. So let's get into making a glockus. So you also pass this down.
One heavier.
Yeah, that one's beefier.
What'd you say, this is the one chamber on this side, and another chamber on that side, same,
Yeah,
split half?
yeah. So essentially, this one got a little damaged in transit, but here's sort of a metal copy of what that core looks like. And so there's one of these, and then there's sort of this isomer.
Right,
on
so
the
I
other
can see
side.
these little ribs in here.
Yes.
Ooh.
So the way the molds go together is they start with 3D printed mold. And so this is PLA. I just did on the MakerBot. I actually did on one of the MakerBots that lives back there. So Resistor, having lots of MakerBotters at it, we tend to have a supply of 3D printers just sort of on hand. And so the design method for these guys is I use a lot of SolidWorks. I've been doing SolidWorks for a long time. It's really easy to Boolean things in SolidWorks, so I start with the shape I want and the internals that I want, and I can Boolean it with other shapes to make the molds. And so even generationally, I can go back and be like, I want this as a core. Well, I can turn that into a two-part mold that makes that core. That's these guys. These are the two-part molds that make the core, and so this made that. And then casting the two-part molds together, this makes this. And putting that inside of the mold, yeah, I know, it's a process. But putting that inside of this mold makes a glockus. So two of these guys, right hand and left hand, go inside of the mold, gets closed up, silicone gets cast, and then you melt out the waxes and you have the finished part.
So you made this thing,
Yes, yeah, that's just a pewter. You know, that's stovetop casting alloy. Yeah, feel free to hand it around. Yeah, the arms broke off in transit because it's been knocked around a bunch, but that's just from this mold right here. Yeah.
Got it.
how much trial and error did you have? This is mold number 1 in your series.
Oh, this is probably 5 or 6.
Okay. So what were the major issues with the first 4 or 5?
So the major issues were not having the core the correct distance away from the walls. So shrinkage is a factor. So each material has its shrinkage or expansion as it cures. So silicone will shrink a little bit less than 1%. The wax will shrink depending upon how quickly it cools. Either the wax will crystallize on the outside and then the inside will sink, and that leads to a pretty dimensionally stable part. But you run the risk if the mold is cold enough that it will prematurely freeze the wax, and the wax will not fill to all of the detail. On the other side, if the wax is very hot, it will cure or it will crystallize unilaterally, so everything will shrink up at once, and you can get to up to 4% contraction in the wax. So a lot of the waxes I use are jewelry waxes. So they come from jewelry suppliers like Rio Grande. You can be pretty picky about the properties of your wax. So I use a thing called an aqua wax, which is just a pretty rigid plasticky wax. There are other ones that are more gummy. The trade-off is the really rigid ones that are nice and dimensionally stable are also more brittle. And so you get this problem where they're easier to trust in the mold staying dimensionally stable, but you stand a better chance of snapping them accidentally while demolding them. Trade-off. So the process with this is, print out all the molds, cast all the molds in silicone, and then some of them are for the final block, and some of them are for making the core. And so if my wax is heated, and it's not quite there.
Oh, I thought that was coffee.
I was going to drink a beer.
I'm very, very into being as efficient as I can possibly be in my company. Partially because I'm cheap, and partially because I don't like having a high operating cost. Like if I can get away with doing something a happy way, if I can find an industrially made product that's made in high volumes,